Okay, I want to give you a few more notes about endothermic. Y'all are going to hear my dog. She sees another dog outside. Endothermic and exothermic reactions. I want you guys to take some notes on this, okay? Endothermic. Basically, endo means inside. Exo means outside. Exit. Exo, outside. Okay? In endothermic reactions, energy is absorbed. Energy, heat usually, is absorbed by the reactants, okay? So that means that the outside environment gets cooler. And you learned some of this, you learned some of this in the Ed puzzle the other day. In exo, energy, energy, usually in the form of heat, is released. Okay. In an endothermic, you're going to have energy as one of the reactants. Remember the photosynthesis equation that we just talked about had sun energy, okay? So it could be sun energy, it can be heat energy. It was required to make the photosynthesis occur, so it was actually a reactant, all right? In exothermic, energy is going to be on the product side. And when I say product side, I'm talking about of a chemical equation, all right? So if you have your chemical equation with the arrow, then energy is going to be on this side of the arrow, and on the endothermic, energy is going to be on the left side of the arrow. All right. One more example, one more thing for something that has to do with endothermic is that the product is going to feel cold. So it feels colder afterwards. Colder. And then, as you might imagine, this one in exothermic is going to feel warmer. The product is going to feel warmer afterwards. Okay, so that's some notes that I want you guys to take and memorize that for endothermic and exothermic reactions. Okay, I also want to go over this worksheet with you guys really quickly. It's going to be more like guided notes, okay? And before we start, I want you guys to write down what enthalpy means. Enthalpy, E-N-T-H-A-L-P-Y. And the definition for that is that it is the total heat content of a system. So it's how much heat a system has. Okay? Or a reaction, when we're talking about a reaction. So that's enthalpy. I'm going to read through this and I'm going to just briefly explain what this is talking about. So on your worksheet / notes, it says when hydrogen peroxide is placed on a cut knee, it decomposes to form water and oxygen gas. How much energy will be released when the H2O2, which is your hydrogen peroxide, decomposes according to the following equation? So what they did is they took this situation and they put it in chemical equation form and they balanced it for you. All right, so here you have H2O2 liquid, so there's your hydrogen peroxide. You're pouring it on your cut knee. All right, it decomposes into water, liquid, and oxygen gas. All right, then over here, it also releases 200 kilojoules worth of energy or heat energy. All right, think back to physics. Remember, joules was what we talked about when we talked about energy. Okay, we were talking about kinetic energy and potential energy, but we talked about joules. Well, this is just a kilojoule. Okay, so instead of a joule, it's a kilojoule. Okay, so it is 1,000 joules is what kilo means. All right, so for the question, how much energy will be released when the H2O decomposes according to the following equation? Well, 200 kilojoules of energy is released. It's on the right-hand side, okay? So that makes it an exothermic reaction. All right, the second thing, change 1. When calcium carbonate forms calcium oxide and carbon dioxide, heat is absorbed. What is that going to make it? That's going to make it endothermic. Look at your notes. When heat is absorbed, it's an endothermic reaction. Change 2. Calcium oxide releases heat when shaken with carbon dioxide. Which line best describes these two changes? Okay, so if energy is released, we know this is going to be exothermic. Okay, so which line best describes this? Change 1 is exothermic? No. Change 1 is endothermic? Yes. And change 2 is endothermic? No. We said change 2 was exothermic. Change 1 is exothermic? No. Change 1 is endothermic and change 2 is exothermic? Yes. All right, delta H is basically just talking about our enthalpy, the amount of heat. Delta H, the change in heat, okay? Is delta H positive or negative in an exothermic reaction? In the Ed puzzle the other day, the gentleman told you that in an exothermic, it is going to be negative. Negative for exothermic. Okay. Is delta H positive or negative for endothermic? It's going to be positive for endothermic. Okay, number 5, heat is taken in. Move this up a little bit for you. Heat is taken in, what does that tell you? In is endo. Heat is taken in when ammonium nitrate dissolves in water. This is an example of, if it's going in, that's going to be endothermic. 6, that should be change, not charge. How many kilojoules of energy will be needed to decompose N2O, what does that say, 5 gas? Okay, so how many kilojoules of energy? Well, they tell you right here, 110 kilojoules of energy must be one of the reactants in order to cause this chemical reaction to occur. Okay, if it's got to be one of the reactants, we learned that that is an endothermic reaction. If it was one of the products, it would have been exo. All right, number 7, label the following as either endothermic or exothermic. If delta H is positive, what did we say? That's going to be exothermic. Oh, I'm sorry, that's going to be endothermic. My bad. Endo is positive. Endothermic. Negative is going to be exothermic. Okay, what did we say photosynthesis was? We said that light was a reactant, so it is going to be endothermic. And what did we say combustion or an explosion of some sort? A combustion is just when something explodes. It combusts, okay? We said that was exothermic. Why? Because a bunch of heat comes off of an explosion, right? Exothermic. Okay, we're going to go over the back real quick. Actually, I'm going to let you guys do the back, and I'll let you do the whole back, all right? And you can turn that in with the notes for a grade into this assignment.